So section 5.2 is about adding and subtracting rational expressions. Rational expression being a fraction of polynomials. So to add fractions in general, we need to have the same denominator. And the formula is like this. All it says is if we have the same denominator, we can add two fractions by adding the numerators. We don't add the denominators. So why do we add the numerators? Well, a over b means that you have a 1 over b's, at least if a is a positive integer, right? A 1 over b's, and then c over b means you have c 1 over b's. So you have a 1 over b's plus c 1 over b's gives you a plus c over 1 over b. So let's put this a little more concretely. Suppose you had 3 pairs and you added them to 8 pairs. Then you'd have 11 pairs. It's the 3 and the 8 that you're adding. That's the a and the c. The pair is the 1 over b. Okay? Now if I had 3 pears plus 5 apples, what does that equal? Well, it's 3 pears plus 5 apples. It doesn't simplify. You can't just combine those two into a single fraction or into a single thing. You could say you have so many fruit, right? But that's changing the denominator to something else that is common to both the apple and the pear. So it's kind of like a common denominator. Apple and pear, they're both fruits. So once you change them to fruits, then you can add them. Now, hopefully that's helpful. That's why we don't add the denominators. Well, there's mathematical proof that it doesn't work, so that's the real reason. Okay, so these are the steps that we will be using on the problems that we'll have on the subsequent videos. First, you factor each polynomial in the rational expression. And that would be everything in any denominator, everything in any denominator, everything in any numerator. Okay? And second, you make all the denominators the same by multiplying each by any factor that the other denominator has, but that is missing from the original denominator. Okay, so that'll make more sense. If you haven't done this before, that'll make a lot more sense once we give you some examples. So let me say that again. Make all denominators the same by multiplying each denominator by any factor that the other denominator or denominators has or have, but that is missing from the original denominator. Okay. At the same time, multiply the numerator by the same factor. So if you multiply the denominator by a factor, you have to multiply the numerator by the same factor. Okay? This will make all denominators the same if you apply this to all of the fractions. 3, add or subtract the numerators over the common denominator. So the denominator, once you find the common denominator, that will be the denominator of your answer, unless there's some reduction that happens later. 4, multiply out the terms of the numerator, and be careful with negatives. Anytime you multiply out polynomials, be very careful with negatives. 5, combine like terms, and that's in the numerator. The denominator is still factored. Don't multiply out the denominator. Why are we multiplying out the terms in the numerator? Because you're going to have two different terms if you had two fractions in the numerator, and you want to have one term in the numerator. That is, you want the numerator to be factored so that you can see if any of the factors reduce with factors in the denominator, okay? 6, factor the numerator if possible. And sometimes it's not possible to factor the numerator, so don't force it. 7, looks like a lot of steps, but once you get into it, it's not that hard, as long as you can factor well. Cancel any factors common to the numerator and denominator. That's just reduce, right? Reduce. Okay, so we're going to have some examples of this.